Okay, Dr. Izwandy, are you ready?
Yes. Yeah.
Okay, so let's start now. Good morning, ladies and gentlemen, and Assalamualaikum warahmatullahi wabarakatuh. Selamat sejahtera. Selamat Hari Raya Aidilfitri. I hope it's not too late to wish our Muslim friends from Malaysia and all around the world Selamat Hari Raya, and it's a custom in Malaysia for us to say maaf zahir batin as well to all of you. Thanks for joining. I apologize for this 12 minutes late today. There are some technical issues in the beginning, and we are glad today, but for the May 2022 edition, we are having Dr. Izwandy Idris, who will introduce to us the importance of worms, the wiggly creature he calls it. And he will be focusing or sharing with us some information, very important information to me, about bristle worms or polychaetes. Very little is known about these creatures in mangrove. I see them often. That is when I see them all around the mangrove very often. But I pay very little attention to them until I know you. So and we will know more today of the secrets, of the importance of the roles they play, and what benefits do they provide to the ecosystem. At local scale, at larger scale. And perhaps I was told also that Izwandy will highlight to us of the some economic potential, socio-economic potentials that can be provided by polychaetes in mangrove. So we want to know how many species they are that we know so far. Pretty much what do we know about them, So this will be introduced by or will be discussed by Dr. Izwandy Idris today. Dr. Izwandy is the head of South China Sea Repository and Reference Center at Institute of Oceanography and Environment, better known as INOS at University of Malaysia, Terengganu. So the second presenter or speaker from UMT, we had Dr. Maiza last month, and we have Dr. Izwandy this month. And I first also would like to thank everyone for joining today, either on Zoom or on YouTube. And thank you for the continuous support. I see familiar faces. Thank you. Thanks everyone for joining today. Okay, we will have maybe about 40-45 minutes lecture by Dr. Izwandy, and then followed by maybe 15 to 20 half an hour discussion, depending on the time and availability of Dr. Izwandy. And we will just do that today. So thank you again, Dr. Izwandy, for accepting our invitation. And thanks everyone for joining. So let me just stop sharing this screen, and I will let Dr. Izwandy now to share his screen.
Okay. Just so much.
And with that, Dr. Izwandy, the screen is yours. Okay.
All right. Thank you very much. I hope you can see my application now. Let me just start the PowerPoint. See, which one that you see right now? Is it presenter view or the audience view, the viewers view?
We can see the first slide now. Yep.
The first slide. Okay.
It looks good.
Okay. Let me just swap it so that I can easy for manage. Okay. Assalamualaikum and good day, everyone. I think we still have time to say good morning rather than good afternoon. First of all, I want to apologize if my voice is not very clear. Unfortunately, got caught with flu and a bit of cough. Started since Monday. I think because of the Raya. Traveling quite a lot along the peninsula for Hari Raya celebration. I think most of us did the same thing as well. And thank you again to Dr. Idris for inviting me to share some information and some knowledge, some facts about this organism. Largely unknown to us. Many people see it when they went to marine ecosystem, but sometimes, just to ignore or doesn't really bother. But that's the same thing happened to me until I started my PhD in 2010. Because my research project in my undergrad focusing on gastropods, and then my first semester working on bivalve oysters. and then I have opportunity to do second master and working on sardines. And then for my PhD, I chose to focus on polychaetes, and I think this is the best decision I ever made throughout my academic career. Lots of opportunities, lots of information that I found by looking at this tiny wiggly organisms that can be found almost everywhere in the marine realms. All right. So I'm from RRC, South China Sea Repository and Center. At the same time, I'm also a member of Mangrove Research Unit. Both units are in INOS, Institute of Ocean Life and Environment, UMT. All right. So let me see. All right. So scope of my presentation this morning is about generally about polychaetes or polychaeta in terms of systematics, general shapes and habitat, ecosystem function and services, and then polychaete for mangrove conservation. Why I choose the first 2 points is more general because polychaete again can be found in almost everywhere in marine realms. It can be from intertidal or well, looking at the current systematics and data, polychaetes can be found almost everywhere. You can find polychaetes in on top of snowy mountains all the way down to the abyss 4,000 meters down below. And then lastly, how we relate that with the mangrove, and also touch a bit about my research that we conducted since 2010 until now. I think about more than 50% of my research focusing on polychaete from mangrove ecosystem. There are still people trying to come into this program. Just admit there, Dr. Idris. So in general, you will see throughout my presentation, I will intentionally using the words annelids and polychaetes. There's a reason behind it. But for at the moment, what we call as polychaete is segmental worms under phylum Annelida. And why we call it poly, because it's obvious, because many bristles. So that's where the bristle worms terms come in, right? At the moment, we have about more than 20,000 species and more than 80,000 families. But in terms of systematic, in terms of classification, it's relatively, I will call it relatively unstable, because for the past 60 years, the position of polychaetes and all the classes within the phylum sometimes change quite significant. And let me say just now, you can find polychaetes. Well, most of the polychaetes in the context that we're talking right now can be found in marine environment, but there are polychaetes that can be found in freshwater. If you have a chance to, there's one polychaete genus described first. The first species discovered from Sabah. The marine, the boring worms, boring on freshwater snails in Sabah, and they are also terrestrial polychaetes. Now, people usually associated polychaete into 2 living conditions. One, we call it free living or errantia. It's like earthworms. They can be found in fauna within the sediment, or epifauna crawling on the sediment, or there are some pelagic as well. You'll be surprised that there are 3 families, polychaete families, that obligate or primarily living in the pelagic environment in Necton. They are also, we call it sedentaria, less motile. It's either living in a tube. For those who are divers, you usually see Christmas tree worms. It is a worm. Feather duster worm, it is a worm, it is a polychaete, and also spaghetti worm. So this is an example of organisms that living in a tube or in a burrow, basically like having a permanent hole in the sediment, and that's where they spend most of the time there. All right, so in terms of size, polychaete can be very vary in terms of the size. You can have a very small polychaete about 1 to 2 millimeter, like the one in the petri dish. That petri dish is very sedimentary, because the sediment that we caught from the 4,000 meters in the abyss when I went for expedition in 2017 in Australia. So we found lots of interstitial polychaetes at depth. Now, if you go to the bottom, the size become bigger. That's from mangrove polychaetes from the West Coast Peninsula. You can see the size, the body width about 1.5 centimeter, and the and the length is about half a meter. You can imagine how the abrupt changes from a very tiny scale size into that size. All the way to the right, you can see the late Christian Foucault now holding Inertia apparatus or the bobbit worms kept in Smithsonian Museum. That can grow up to 3 meters long, and you can see it looks like a snake, but it's not a snake; it's a worm. That's how big polychaetes can be. So the main morphological features of polychaete is like while in to put it in perspective, related, it's like a centipede, like lipan, right? Because you have a legs, you have a head, you have a anterior posterior region, and then they have what called a setae, or relatively translated as cuckoo nails that used either for locomotion or for defense as well. So the shapes varies. We have a commonly, especially for sedentaria, erranteria species, they have a vermiform shape, or like earth worm looks like. They can be a plant-like shape, like a Christmas tree worm, and then they can be hybrid. The vermiform shape of polychaetes can live in a tube, and then, but at the same time, they can move in and out freely. But they have the house, right, in the form of tube. Likewise, otherwise, like plane-like shape, for example, this Christmas tree worm, they cannot move in and out. They cannot move out from the tube freely, because that's where they stay throughout the life cycle, and they will die within that tube as well. And they will, the length of the tube is perpendicular to the size of the coral itself. So just give you a perspective how diversity of shapes of polychaete. So this is from quite an unique characters from the very classic book, basically in 2000. There's a new publication published last year by Lee et al. Basically about the same. So just show you the diversity of shapes of the anterior, the head's variation of polychaete. You can see from A, like a very worm, earthworm-like, all the way to the K, like a brush, and this one J is a spaghetti worm. Some of these especially for J and K, you never see the main body, the repeated segments. You can only see the anterior part, because they are very sensitive to vibration. So normally when people or any organism came near to it, it will retract itself into the burrow or into the tube. Again, so this is the parapodia, or the kaki part, the feet part of the polychaetes. So you can see the all sort of variation that we use for identification, and the position of the setae, the nail itself. And also the nail also varies. You can see different species, different when you have different kind of setae, and they use it for different purposes. Like the T1, the unchini, is for those polychaetes that live in the tube, because it can hold the organic part firmly, so it's very difficult for you to remove it by force and the polychaete from the tube, because they have this kind of setae that grabs the tube wall firmly. Please let me know if you can hear my voice well, because I can happily to repeat it, because my voice, because I have a flu. Well, this is a polychaete that you might see in the marine ecosystem, not only restricted to mangrove, but if you have a chance to go underwater, spaghetti worms, this is how it looks like. Clam worm. If you have the opportunity to go to mussel raft or oyster farm, you can look in between the shell sometimes if you're lucky enough, you can see this worm crawling between the shells. This one falling worm, this is collected from mangrove from Terengganu. So this is relatively very small, about the size of the length of it is about 1 cm. But this is one of the pests that eroding the structure, especially made from wood in the mangrove, in the brackish water system. The lower part, the fireworm, this is very dangerous. In fact, it's been classified as a venomous organism in 2020, sorry. So there are few cases people been stung by or been injected by the city of this fireworm because the city have a microcapillary that can release the venom into the human skin, and the worst part is the city can be break off, so the front part of the city can remain in your skin. So please be careful if you find this shape of worms in the intertidal zone. Try your best to avoid it. I think 4 years ago, I was interviewed by TV9, if I'm mistaken. There were cases of this fireworm in Port Dickson. So my advice is please ignore and don't ever try to hold this fireworm. Okay, so it varies, the shape, the structure itself very different within this one called polychaete. Now, why I say the systematic is really unstable. So previously, polychaetes, oligochaetes, the earthworm belong to phylum Annelida. But after several years of molecular studies and also cladistic analysis, scientists concluded that at the moment, Annelida is synonym to Polychaeta, because all, like even the earthworm, the leeches, belongs to class Polychaeta. So in the nutshell, Annelida is a synonym to Polychaeta. So, but now, even so, this is still unresolved. So that's why they are still considered class which is supposed to be under Polychaeta before, but now it is separate because become its own class. And then this is another one that haven't been named yet. This is where the peanut worm, the penis worm, the Sipancrates also belong to this group. And all this direct linkage to Polychaeta or Annelida were all like what we see now as worms, including oligochaetes and leeches. So I would say my opinion is the current systematic is relatively unstable until we find further evidence to place these segmental worms into which class or what should we call it, whether it's still Annelida or we should dissolve the obsolete Polychaeta and remain use Annelida throughout the naming system. Right. So I think I'm done with the some introduction about the polychaete. So hopefully all the audience have some idea what polychaete is all about in terms of shapes, systematics, also habitats. In terms of molecular function of polychaetes, in general, we can say that polychaete is one of the food source for other organisms. So it provides protein for fish, birds, and vertebrates. Polychaete also involved in bioerosions, especially for an area where new coral growth. But at the same time, there are several polychaete species helps in the formation of reef. So, for example, in the point number 3, so we found a polychaete reef in Jeram in Kuala Selangor, but there are also some polychaete reef recorded. Although it's not properly published, but there are polychaete reef recorded in Penang near the Masjid Terapung, and also in Morit itself in Pantai Kelanang. So it builds like a bump, all those straw-like structures full of polychaetes, and but at the same time it provides spaces and substrate for other invertebrates as well. So that's over the time they accumulate sediment. But in some area, this reef can be dissolved over the time due to the pressure from the physical factors like storm. But for us, okay, so services by polychaete, we can use polychaete as bioindicator to measure the level of pollution. We can use polychaete for toxicology tests. This is very common for recreational fishing. Like in Malaysia, we call it pumpon. If you go to orang asal, they call it ruat. Some also call it umpun. It depends on the area where you went to. So this is one of the common use of polychaete as bedworm it's either for recreational fishing or by artisanal fishers. So as for now, there are about 60 species from 12 families commercially harvested worldwide. In Malaysia, I will show you later. This is from our research. There are species that found in Malaysia already included in the list. So the number of it up to the 60 species of polychaetes used as bedworms. Now, this is one of the news that we found, I think, in about 10 years ago. So it's quite a good business. So one lady can obtain about 1,000 ringgit a day just collecting worms. Is it really unknown to many, but somehow this is how they get from just collecting these invertebrates. At the same time, if you go to overseas, in many, especially in Australia and Europe, and also in China, they commercialize the bedworms. This is one of the products that we produce as dry bloodworms. If I'm mistaken, this is from Family Unicide, and they sell it, I think, in Australia about $13 per packet. I bought it 2 packets in 2013 and still with me today. I received a lot of demand, especially from recreational anglers. Now, this is another surprising fact. Actually, the marine worms industry worldwide valued about $7.5 billion US. Something that we never heard of, and then something that we think is a very minuscule or just a worm. Doesn't value much, but actually it's lots of money, right? They use it for recreational fishing, for bait, but they also use for aquaculture. This is the value of the. This is an example of the most expensive polychaetes that have been sold worldwide. All of these are from European or temperate species. Sanguina and Neosporins are all from the UK and also Europe. They dominate the worldwide trades of polychaete business. But quite expensive. You imagine for this Blaumaglacera dibranchiata, mostly collected from Maine in the US, East Coast, $192 US per kilo. That's about 600 ringgit, Malaysian ringgit. Quite inexpensive. Now, we can also use, people use polychaete for aquaculture species to feed the broodstock. This is one of the studies done researchers from Nottingham in Malaysia. They found that the 4 species that you use for bait have a high lipid content, the PUFA, polyunsaturated fatty acids, and also the protein level also very high for the species found and used by our fishermen for baits. And these 4 species are suitable replacement for aquaculture feed, because at the moment, most aquaculture farm, they import the worms from China and from UK to feed the broodstock in the frozen form. So we have now potential to obtain our local worms to provide to feed our broodstock for aquaculture industry. This is an example of farm in the polychaete farm in Netherlands. So one of the trademarks is the pathogen-free worms, and then they sell this worldwide. In fact, they sell the few aquaculture farm in Malaysia also bought the worms from this farm to feed the broodstock. And then another use of polychaetes for us is to wastewater treatment. So in polyculture, there are several studies. This one study referred in 2021. They use polychaete to treat the waste nutrient from shrimp farming, and at the same time, the species that they use, the polychaete species that they use in this experiment, the blood is very useful for in medicine. I'll show you later. Just now. Okay, this is another interesting potential use of polychaete. Some people sound a bit too much, but for some indigenous or culture, they treat polychaete as a fish. Maybe some of you have heard about palola worms in the Pacific Islands. Refer to certain species of polychaete from genus from family Inicidae, and they eat it as during the special occasion. If you don't mind, I would like to share you a short video made by my friend from Indonesia, Dr. Joko, and how they collect the worms and cook it during special occasion. I think 2 times a year. Let me see if I can play.
You want to increase the volume a little bit, Dr. Izwandy?
Yes, let me try. Oh, sorry. I think that's enough because we are near to lunchtime. But that's it. It's a common. People use polychaete as a protein source in the islands in Western Pacific and also in some part of Indonesia. And also during my study, there are some Orang Asal tribes that also consume polychaetes, and they said it has a parodontia effect. Well, we never know whether it's true or not. Now, the other part, the use of polychaetes. Now, there are studies that found that the blood from polychaete can be used as a blood substitute for human, because they have 4 times more in terms of oxygen affinity compared to human hemoglobin. So this is a species, Rhinocolla marina. This is a temperate species. But we also found that most they call it bloodworms also have a similar content. So there's a positive for other species, especially in tropical region, that might be useful for blood substitute for human as well. In fact, they tried during the first outbreak of COVID, they have tried to use this blood from polychaete to help people that have a breathing difficulty and also to transplant organs. Then the one of the latest is the producing of silver nanoparticle from the extract of polychaetes. I have to reiterate from the extracts, the biosynthesis, not by opening the cavity of polychaete, you can find the nanoparticle, but through the extract and the synthesis process. Because in not only silver nanoparticle, I'll show you later, we also found out that gold nanoparticle also can be synthesized using the extract of polychaete from the polychaete mangrove found in the mangrove in Malaysia. Okay. So back to our local contents. So what we have in Malaysia at the moment. So based on a study in 2013 by myself and my PhD supervisor, Prof. Ashad, we found out based on the literature, as in 2010, there are 64 species that have been identified from Malaysian or the so-called Malaysian territory, that's including Malaya. But I think until now, from that year, from 2013 onwards, I think the number has increased. I haven't compiled the latest checklist. We have about more than 80 species. But out of these 80 species, 18 species come from mangrove ecosystem. I think studied by Dr. Sasi Kumar, for example, in 1970s, there are several species from Kappa mangrove forest that we included in the list. However, in terms of this list, identification accuracy is a problem because some of the species identified, they label it as cosmopolitan. But our recent studies found that from the polychaete community, some species that we call it cosmopolitan, for example, the famous Diopatra neapolitana, the cheatworms, Maphysa sanguina, Hydrodis elegans, they are not actually cosmopolitan per se. They actually have a very restricted distribution. For example, the sanguina, Maphysa sanguina, only restricted in the South England until Netherlands. So those species, the species that identified outside the distribution area have a very, it's supposed to be a different species, not the species that been identified before. So in terms of the actual identification is a problem. So it's a challenge for those working in taxonomy to reassess the species that be identified by previous scientists and whether they are actually the correct species or they actually belong to undescribed diversity within this region. So in terms of my research, so approach for my research for polychaete research in Malaysian mangrove. When I started my PhD, my research in 2010, so we are divided, either we're focusing on a very taxonomic work and choose one family and do some revision, or we need to do something that more relatable to people. Like I said, when I told my mom that I want to do a PhD on worms, and her basic response, belajar makin lama makin belajar cacing saja. So how we relate it to local people, our laymen, whether this is very useful. So we decided that focus on the target species that have ecosystem services that are very profound and has a commercial value. So it's relatable and close to people because people can see how it relates to them. Oh, we use it for bait, for fishing. Oh, we can sell it. We can get earn some money from it. So, but people don't know. They just call it the local name, Kumburwak, but we don't know what the scientific name of it, how it looks, how it functions in the ecosystem, what is the other application that can harness from this species. So that's why we can speak to the same language to the people so that we can relate and they can understand and appreciate the work that been done on this organism. So in terms of criteria for commercial polychaete species, this is based on a study by scientists in Italy. One, the species should have a large adult size. It has a wide distribution, and for Malaysian context, use as fishing bait. The other three components is also important, but for our current study, we don't we put it on the KIV first because we want to get the interest and also the support from the local of our research. So based on our study, there are 4 species of polychaete within the mangrove system that have been harvested for and used as bedworm. So there are two species from the same family, initially from same genus, Maphysa. I think you can guess where the type locality is from for the first species, Maphysa moribidi, and this is how it looks like in the natural habitat. It's an infauna species. You have to dig within the mangrove root to take it out, and it's quite long. The longest I found about half a meter. The other one, we still haven't sure the actual name of it, but because it's quite difficult to find the sample, the sanguine now. But people call it rot bakau. The second one, you call it ruan or pun sarung, the chipworm. This one mostly found in the tidal adjacent to the mangrove area. Okay. This is the hybrid because it have a vermiform shape, but it live in a tube. This one is mostly can be found within the rotten front of nipa. We call it rot or pumpa nipa. The first record in Malaysia was found recorded in Sabah, Kota Kinabalu, but I think the second record was found here in west coast of Peninsula. So in terms of price, quite a good business actually if you really work seriously on bedworms harvest. So for example, the first Maphysa moribidi can sell for 5 worms for about 10 ringgits. For another rat nipa is even more expensive, about 10 ringgit, just 1 or 2 worms. But for the particularly is bit low because this is the least interest by anglers, because it depends on the experience by the bait diggers. Some bait diggers are novice bait diggers. They only can get the tubes because the worms are very sensitive to vibrations. Once people come nearer to the tube to dig, they will bury themselves further, just leaving the empty tubes. So some anglers doesn't really like to purchase the patra for fishing. Now, when we work on this species, we try to find what are the applications that can be found harvest from this identified species, not only just for fishing, but anything that can be enhance the value and to make people more appreciate the diversity of organism in our mangrove ecosystem. So this is accidentally found in my study. So one of the specimen of Diopata, the rot sarung or the chipworm, apparently have a very small head regenerated from the anterior part, the missing anterior part. So they have a very small head. Surely it's regenerate from probably incidents fed by the fish or gastropods. So we conducted several studies, and then we found that if you further study on this species, there's a possibility that we can use it information or the extract from this species for medicinal purpose, especially for neuro disease. So one PhD student has been graduated just looking on the nervous system of this worm. Right. So let me show you again. So the issue here, this is the anterior part of the patra. So the anterior part is the one that is exposed to the environment, especially during high tide or low tide, because the worm needs to go out to feed, and then come back and retreat back to their tube. So the problem is, if there are potential predators that feed on this anterior part of this worm, be it fish during high tide, or birds and other invertebrates during low tide. So there's probably evolutionary adaptation of this species to make sure that they can still live even though they're losing the anterior part, including the brain. We're still not sure in terms of this phenomenon, but if you look at this video, I'll tell you right now. Let me just reduce the voice. So you can see all these snails crawling towards this worm, but they're only focusing the anterior part. they're not feeding on the throughout the body of this Diopatra, only focusing the anterior part. See? So only feed the anterior part. So the anterior part is prone to missing, be it by the bird's predation, or in this case, snail predation. So if this worm managed to crawl back into its tube, after several weeks, the head part will grow again. Okay. So I used to make jokes with my student that if you don't like your face, if you have this opportunity, like my face not so nice because all those pimples, someone can just cut my head and then I rest in my dorm for 2 weeks and then come back with new heads and new flawless skin. So that's that if we want to akin it to what happened to these polychaetes. But it's very interesting because if you look at the terrestrial concept that like our lizards, cicak kat rumah kita lah. So if you cut the nails be removed voluntarily by the lizard to the stress, and it grows itself. But now it can grow its brains that missing due to predation. So there's something interesting within the nerve system, the blastema cell that can initiate the healing process and also to regenerate and control the regeneration process in the end, build the new brain for this individual. Also, based on a study that by Singh et al. In India in 2004, we found that we try to synthesize nanoparticle from polychaete found in the Malaysian mangrove. So working on this species, Mafasa Marudin and also Diopatra, so we can find that there are potential for medicinal wound healing products from the extract of worms or marine worms, especially from the mangrove area. If it's not similar, if it's not better, it's similar with the one that we use currently from the sea cucumber. But we need more study, more valid lab reports to finalize this outcome and then thinking about the commercialization from this product. Another one that I mentioned just now, the synthesis of nanoparticle. We try with the silver nanoparticle and it's successful with one species. And then recently we tried to synthesize gold nanoparticle using the extract from this polychaete, and also very promising results. So it has a lot of potential in terms of electronics, in terms of coatings. In fact, if you find a way to embed this nanoparticle in the clothes, it has very antibacterial properties so that you can wear your clothes, especially for military fatigues, be in the operation area for few days without without soiling your clothes because of the sweat. So these are the potential applications from the two species that we've identified from the Malaysian mangrove. So we can use the species as fish bait. We can either dry it like the one that we sold overseas, or we can set live like you find along the roadside road stall in the PD, in Selangor, even in Johor. We can use it for aquaculture, sell it as a frozen or fresh product. You can process it and mix it with other materials to make it a grow of pellets. You can use it for environment, for wastewater treatment. You can use it in the pharmaceutical or cosmetic, wound healing or brain study for nerve disease. We can produce synthesized nanoparticle. From this nanoparticle is either silver or gold nanoparticles. Lots of other application industry. It can be medical, it can be coatings, it can be textile, it can be electrical and electronics. I think at the beginning of pandemic, there's a lot of people, there are companies selling sanitizer with a silver nanoparticle inside that they claim to have antibacterial, antiviral properties. We can, if we can optimize the method, so we can produce the raw materials of the silver nanoparticle to the industry using the extract from Malaysian polychates. Now, how can I think towards the end of my presentation? So, how we use this information with the mangrove conservation agenda? First of all, there are polychate species in Malaysian mangrove are still unidentified or undescribed, right? We are talking about polychate species from the Peninsula Malaysia, but there are more species that haven't been described in Borneo, in particular. Even in fact, in mangrove area itself, there are lots of undescribed species that we don't know yet what are their potential that we can harvest from them. Their conservation potential is still untapped. And then if we're losing more mangrove cover, we are losing unknown diversity, and thus we're losing potential waste collection that we can obtain from these undescribed species. So we need to protect the mangrove because these are our bank of resource for Malaysia. And the other thing is, bed digging, although it's unregulated and not properly looked at by authority or in academics, based on previous study, bed digging is unsustainable and damaging. In fact, in our study, we found out to collect the root bakau, basically you are destroying the root system of mangrove. So we've been shared or been told by the local people that there are some bed diggers that falling down the mangrove trees because they want to dig as deep as possible within this mangrove system to collect as much as possible the polychates for beds. So we need to look at it. There's no study on the impact of bed digging in Malaysian mangrove system, and also the heavy metal turnover. And I think the impact of blue carbon as well. We need to look at it. Well, basically we are sitting on top of gold mine in the mangrove system, yet unaware and unfortunately destroying it. All right. So what's next, especially for my research group? So we are still looking at identifying polychate species from other mangrove areas, possibly new candidates for various applications. So whenever we talk to stakeholders, look, we need to conserve this area because there are species that we think that is good, that can bring millions of ringgit to Malaysia from this species. We need to know. So this is what we're doing right now. I know, and then exploring other possible applications for other species, raising the environmental value of species and ecosystem. So I think we need to recalculate again the value of mangrove system. Is not just the vegetation itself, the macrobenthos like the oysters or the clam, but need to include other invertebrates as well that have potential. Like this polychate in the global arena is 7.7 billion US dollar. So if you downscale it to Malaysian perspective, it's quite a lot of money, and I think will project the value of our mangrove system quite significantly. And then my third objective focus for the current research, understanding the biological requirement of identified species for sustainable use through recirculate aquaculture system. Because some people quite opposed to the aquaculture approach, because they say you will destroy the mangrove because you need to build the pond, like the shrimp pond, for example. But the RAS system, basically you can build the system anywhere because you don't need to dig the pond. You can build on land, and then you can do it anywhere, even in Putrajaya or even in on land far away from the mangrove. But you can still culture the mangrove species through this RAS system. But we need to know the biological requirement, how they, what kind of the best temperature, the best salinity, the best food, the spawning season, the spawning pattern. Then we can manipulate and then culture through the RAS system. And then the fourth one, understanding the ecosystem function of polychate in mangrove ecosystem. remember the tube-worms, most tube-worms found in front the Avicenna and Sonaria zonation, which means in the tidal flats. These tube-worms accumulate organic matter, plant debris, and also sediment. And we found out they are the sediment surrounding the tubes is finer than the area without the tubes. So there's a possibility the presence of tube-worm somehow assists in the land accretion, a part of the mangrove root system itself. So we need to look further on this aspect as well. So in the end, polychaete is not just a worm. There's more than that you can tap on it, you can learn with it, you can appreciate it, and then we can use the inspiration to bargain with the stakeholders to protect our mangrove ecosystem. I think that's all from my presentation. If you have any question, feel free to ask me. Thank you very much. But before people start asking, this is my photograph during my PhD days, so looks different.
You look younger then.
Yes, obviously.
Thank you very much, Izwandy. This is an eye-opener for me in particular, and possibly also to the rest of our viewers today. We pretty much neglect this very precious organism. And I like one of your final points just now about the value. Putting value on ecosystem is not just the visible creatures like the trees or some major fauna or macrobenthos found in mangrove. We neglect the price of or the value of polychaetes that play a very important role in regulating sediment processes. Yeah, and in fact, you also mentioned about how they're potentially good at treating wastewater. So that's amazing. Yeah? And I'm pretty sure, as you mentioned, I think you've highlighted so far you found like 18 species of polychaetes in mangrove. Yeah? And out of maybe 80 plus species or all around the tropics of the world, maybe?
In Malaysia.
In Malaysia, okay, sorry. Yeah, pardon me. Yeah, so there you go. I mean, and if I may, how many of you, Dr. Izwandy, in your team are working on polychaetes?
Well, myself, and then there are people working on chemistry part, and then on the biological part, and then I have students also working on the different group of from different ecosystem. Like I say, I'm not 100% working on the mangrove ecosystem. There are people working on the impact of breakwaters using polychaete as a proxy, and also cryptid fauna in the coral ecosystem and using polychaete as a proxy as well.
Yeah, but specializing on polychaete diversity or polychaete ecology alone, I think maybe a handful from Malaysia.
In Malaysia, I think the taxonomy there are 2 people, myself and also Yusuf Shuaib, also from UMT. But there are other people, I think maybe occasionally work more like ecology rather than taxonomies.
Yeah, so we definitely.
From taxonomy point of view, we are a bit worried because some people they identify species using the old literature. This is where sometimes species that supposed not to be here, temperate species by identified as a tropical species. So we need to be a bit careful about this.
Agree. So definitely, yeah. I mean, taxonomy, as we all know, is declining discipline. We're losing people working on taxonomy, and I think we need extra help here. Yeah, especially from Ministry of Education, Higher Education, Ministry of Nature Resources to like support fundamental research. Yeah? And of course, all our worries about all the bigger issue like climate change, about how mangroves ability to sequester carbon, but then these organisms, minute organisms like polychaete play important role as well to maintain or to sustain the ecosystem. So we need to push and promote research, fundamental research like what you're doing, Dr. Izwandy. So it's another challenge for you also to recruit more and train more taxonomies looking or focusing or specializing in polychaete diversity. Yeah? So there's a challenge for you, and a couple more suggestions. Yes, in your way forward for more upcoming research. Yeah, I mean, this is another point, yep, to push for mangrove habitat conservation. I like that you highlighted that we haven't really understand the whole ecosystem, and quoting Tan Sri Saleh, he mentioned if we lose forest, deforestation, if we lose mangrove forest, we will. It's like burning a huge library of knowledge and information. So we don't even know what's happening, what's inside the system, and we'll lose it, right? So this is a challenge that we are throwing to all state governments to pay extra attention. And I also like your idea, your proposition on aquaculture. It is not just to farm polychaete, but it applies to all ecosystem aquaculture activities as well. They don't necessarily need to clear mangrove to build aquaculture pond, right? It can be done far away or further away, maybe in industrial zone, with proper settings and requirements. Yeah, so that's a very good point there. So let's open the floor to the floor if there's any question. I haven't seen anyone posing any question from the chat, but perhaps you would like to hear some voices, or maybe you can raise your hand, or you type in the chat if you want. I'm so glad to see just now Dr. Daniel Baskaran from Pulau Banding. He was with us for a while. I don't know whether he's still with us, but if yes, if you have any question to Dr. Izwandy. Anyone? Yes, there's a question from Ms. Nurul Ashikin. Yes, you can.
Maybe I can ask here. So,
yes.
Assalamualaikum, Dr. Izwandy. Thank you very much for a very interesting sharing about the polychaete. So today I learned a lot about the polychaete. So thank you very much. So I maybe have a few questions. So first, as you talk about the fireworms, the one that have venoms, toxic. So I interested to know about the distribution of this fireworm. If I'm not mistaken, I have heard you say that this can be found in Port Dickson.
Sorry. Well, the fire. To be honest, I think I would like to repeat or repeat again what I just said. We only have 2 people dedicated working on polychaete in Malaysia at the moment. So I used to say that saya pitching 2 kali pun takkan habis cerita pasal polychaete ni. There are no study right now focusing on fireworm in Malaysia. But there are reports of fireworms in PD, in Perak, in Pulau Aceh. Even I think they are collecting some sample there. In Pulau Redang, and also in I think some part of Johor, I think. Yes, so it basically is almost the distribution is quite wide, but maybe different species.
Oh, okay, understand. Because I'm teaching invertebrate classes, and I'm basically bring my student to Port Dickson. So I didn't know that we have this kind of venomous polychaete. I always told them that the polychaete is not venomous, because I'm not in the marine field. So basically, I'm doing research on insect. So, but yeah, since been asked to teach the invertebrate courses, so that's covered the polychaete lah. So yeah, and today I think I have learned a lot. Thank you, Dr. Izwandy. So the second question about the terrestrial polychaete. So where can we collect or find this polychaete in terrestrial habitat?
Okay, if you look at the current systematic study, the earthworm now fall within the polychaete. So actually,
earthworm, okay.
Yes. Okay. Even the leech as well now categorized under polychaete. So if you, in the broad sense, you can just go and collect the earthworm and say it's a polychaete. But like I said just now, there's no study on terrestrial polychaete in Malaysia at the moment. Tak banyak lah. I put in perspective what we record now about more than 80 species of polychaete official publication. Singapore recorded about more than 600 species.
Wow. Okay.
Throughout South China Sea, about 1,600, if I'm not mistaken. But we only record about 60 or 80 species. So there's the research gap between polychaete in Malaysia and other countries is so vast. So difficult to say. But I think for teaching purposes, if you're using the current systematic analysis, you can say that, oh, let's get the earthworm because it's also for under polychaete.
Oh, okay. Thank you for the suggestion. So maybe my last question, is it easy for us to capture or rare the polychaete? And we have any places that farm the polychaete in Malaysia?
To be honest, it's not that difficult, but you need to know the requirement first.
Okay.
As far as I know, there's no official polychaete farm in Malaysia, but I know there are certain aquaculture farm. They have small polychaete farm that cater their own use.
Oh, okay.
But normally, those aquaculture farm they import frozen polychaete from China or from Europe to feed their stock.
Oh, they're not using our local polychaete lah.
No, but there's a problem with that because if they decided to import live polychaete, which they're possible of they are accidentally released in the environment, so that might be introducing alien species to our system.
Yeah, that can be maybe serious problem later. Yeah.
Yes.
Thank you, Dr. Izwandy. So I think that's all from me.
Thank
So
you.
thank you very much. Yeah.
Thank you very much, Ms. Nurul Ashikin. Where are you from, by the way, if I may ask?
From UM.
UM, Dr. Nurul Ashikin, ke?
Yeah, Dr. Nurul
Okay,
Ashikin.
thank you for your question and your interest. There you go, Dr. Izwandy. We have a candidate for your team.
I'm happy. I'm happy for collaboration.
Yeah, there you go.
I'm happy.
Yeah, sure. We can see about the collaboration later. Yeah.
And that's the intention, that's the intention of this event also, Dr. Nurul and Dr. Izwandy, is to create or to create this platform for networking. So I hope maybe there will be communications in between both of you and your teams to proceed with some ideas. And I'm so jealous when Dr. Izwandy mentioned 600 species discovered in Singapore, listed or founded in Singapore, and 1,600 species throughout Southeast Asia, and only 80 listed or studied or maybe identified from Malaysia. I mean, I'm pretty sure we have way bigger, or maybe similar to the amount found throughout Southeast Asia, right? So there are potential possibilities in understanding more about this. Yeah? So hopefully, with this session today, we've enable some collaboration throughout our scientists throughout Malaysia. I'm pretty sure our friends at UMS, UNIMAS also are very interested on this research, maybe, and we can join forces working on this. And extending from what Dr. Nurul Ashikin's question earlier, we don't need to in fact import, and then that's a very risky business. I mean, importing, introducing them as alien, maybe invasive species. So if we know about our very own species, we may not have to expose ourselves to these kind of risks, and they may be more suitable to our environment as well, and especially to farm other economic fish for economic purposes, or seafood for economic purposes. Is there any other question from the rest? Dr. Kanwal Nazim, our friend from Pakistan. Thank you for joining us. I think she wants to ask a question. Please proceed, Dr. Kanwal.
Yeah. I have a question. First of all, I will highly appreciate the work presented by Doctor. Izwandy, and my question is that here I am working on polycutes and carbon sequestration in mangrove forest. So my question is that uh, if we are working on carbon in mangroves, so what role polycutes are playing? I mean to say, have you any study conducted in Malaysia?
No, to be honest, no. We haven't start working on that aspect. Well. But I think polychaetes somehow have some impact to the carbon sequestration in mangrove ecosystem because they are burrows. So they are introducing oxygen in the anaerobic layers of sediment. So somehow they have some impacts to the carbon sequestration in mangrove, especially the infauna species. Likewise, the tapeworm, I don't really think it's a very significant contribution, but the burrowing species, I think yes. But we haven't worked on this yet. But it's a good aspect to study.
Okay, here we have identified 22 species from mangroves. But as you said that we have you have identified 64 species. So it's a very interesting for me and very knowledgeable. I really appreciate. Really, it's a good work you are doing there. And whenever I will come and I will try to join you in your studies as well.
Yes. Well, I'm looking forward for potential collaboration. In fact, the other thing, the pollution aspect also need to be somehow we can look at because the tapeworm, remember the tapeworms, the Didiopatra, there are several instances where I found they made the tube from the plastic, from the plastic wrapping, the candy wrappings, the instant noodle wrapping, rubber band, and then somehow the worms found it and then they attach it to form the tube. So it's not only the plant matters, all those anthropogenic litters also being used by this organism to build their tube. So I don't know whether they have some impacts to the debris distribution or maybe that impact the hydrodynamics, the sediment rates. We don't know, but it will be interesting to look at.
Thank you. Thank you.
Thank you for the question. Yeah, I think this is very interesting as well. Very interesting angle to look at. Yeah, Dr. Izwandy, of their ability, to basically regulate debris, marine debris within the system. Yeah, so that could be one of the important role. And I'm pretty sure, yes, carbon, their role in carbon sequestration as well. We do not know much about other ways that the system can actually regulate carbon. So this could be another angle to look at. So there you go, Dr. Kanwal. Another angle, another possibility for research. Yeah? Oh, a lot to be learned, a lot to be studied. Dr. Izwandy, you, I don't know. I mean that it will be more challenges for you. Yeah? And not only that, I like that your research and your team actually work also on looking at the production of commercializing these products coming from polychaetes. Yeah? That's another interesting, and I think UMT is very supportive of that. So that's very good of the universities to support this kind of product derived from polychaetes. Any more question from the floor? Otherwise, I have one for Dr. Izwandy. I've heard about polychaete reef, Dr. Izwandy. So, how is that possible? How can polychaetes form polychaete reef?
Well, I think it's a combination with the hydrodynamics at that time. And then the correlates with the spawning pattern. So when the spawning occur, these fertilized larvae now find a way to settle, and then the right time and the right condition allow them to settle in one place in mass. So that's where they start to develop the tubes, and then somehow after that, other organisms start to use the substrate as a habitat as well. In some places, the reef is temporary. It depends on the hydrologic condition as well. Like I mentioned just now, even the jeram polychaetes, there's a model called it the jeram model. It's been stated by the British researcher in early 50s. But in other countries, this polychaete reef comes somehow a bit nuisance because it overcome the coral growth and other invertebrates in the reef system. Is different than oyster reef. Oyster reef, they are like a semi-permanent because of the shape, the structure of oyster, the shell or oyster shell itself. But the oyster reef, the species that develop the reef, the tube is not as hardy as the calcium carbonate. They build mostly on the gluing the sediment and organic matter through the organic cement. So they are not permanent. And then somehow it impact the condition seasonally, I would say.
Right. Thank you very much for the explanation. And yes, I mean, interesting. Yeah, thank you very much, Izwandy, for your time. Yeah, for this knowledge sharing. Yeah, I guess that would be the last question for today. But you can always, I'm pretty sure this topic itself is alien to many, so you can always revisit Dr. Izwandy's lecture. I mean that's 101 to 202, maybe 303. We're talking about commercialization of polychaetes in mangroves in Malaysia. So I think we learned a lot, and thank you very much also to highlight and to devote yourself to this very fundamental topic, very important topic in our mangroves. Yeah? And as you've correctly highlighted, with only two maybe key person looking at polychaete taxonomy in mangroves, it resulted to only a few species discovered in Malaysia. Yeah? So if we have more, we would know more and better about our polychaetes and about our ecosystems. Yeah? Species listing doesn't reflect the real situation in one country in our ecosystem in particular. It includes, it requires support or research being carried out by researchers throughout the countries, throughout Malaysia and other countries for that matter. So it doesn't really reflect the richness as well. So, but don't neglect this point. Yeah? Maybe because if we know of these properties, it will push or it will influence decision on protecting these habitats. Because if we have to start, but this is a message particularly for managers, for state authorities. Don't only look at this ecosystem, mangrove in particular, just the trees, or just the commercial value of transforming it into aquaculture ponds, for example, or other physical development. Look beyond trees, look beyond this direct economic income we gain from aquaculture ponds or any other physical development. These habitats evolve. These habitats are dynamic, and these creatures, these small creatures, actually are the agents that play important role in regulating the systems and the processes. So there you go. We learn very important topic today, and there are more to be understood, to be studied. And I hope in a few more years, Dr. Izwandy, your sub-team, I will call it a small team of polychaete researchers will grow bigger, and hopefully we can hear more updates from you in several months or years from now, and perhaps you will discover maybe 600, 700, 800 species of polychaetes in Malaysia, and perhaps half of them coming from mangrove, you never know. And yes, so again, I would like to thank Dr. Izwandy and your team for this input, for this knowledge sharing today. And I would like to thank everyone for joining, for all the questions, and for participating in our discussion today. And just to alert everyone, in June, next month, MyMangrove monthly discourse, we will feature Dr. Jayani from Forest Research Institute of Malaysia. So the topic will be, in general, it will be on the sediment and soil of mangrove. So what's there? We know Polycate uses the sediment, the mangrove soil, as their home. So what else can we find? Maybe the chemistry properties, the physical properties of soil from Dr. Jayani next month. So stay tuned. Log on to our Facebook group, my Facebook /groups/MyMangrove to get more updates, and also to share your information. So that is only from time to time, please update us as well with new findings and new publication to be shared with all our members. So again, if possible, if you can turn on your camera for just 1 minute, so we can have a group picture as a proof of attendance and proof of participation for Dr. Izwandy's talk. He can use this to share it with his bosses. So
Bukti kehadiran.
Yeah, that's right. Proof of attendance. But you can also email Dr. Izwandy if you have any further question that you may not think of at the moment, or to initiate some further collaboration. Dr. Izwandy, can you share your email address in the chat? So, or maybe you can just spell it out.
Let me just share in the chat box.
Okay. Okay, so there you go. Izwandy.idris@umt.edu.my. If you have any further question, please contact Dr. Izwandy directly. Okay, so I see Dr. Wan Iriani juga, Prof. Thank you very much for participating. Dr. Izwandy always say roommate.
In this case, my partner in crime lah.
Okay, thank you, Dr. Ishkin. Okay. Anyone else? 10 seconds I give to turn on your camera. Okay. All right, so 1, 2, 3. 3, 2, 1. Ihsan. Muna rendah. Okay. All right, so with that, we sign off for May 2022 MyMangrove monthly discourse. Thanks again to everyone, and hopefully to see many of you again in the next series of seminars. And keep in touch. Happy mangroving, and again, Selamat Hari Raya to all our Muslim friends, and take care and goodbye.